Hi everyone. Okay, let's continue. So for this second example, we've gone through the first half of it and we've come up with at the 5.5 year mark with 3.5% annual interest. We have the future value is the 72.08 and 91 cents. Okay, so I have 5.5 years under this condition of contributing 600 every 6 months for 5.5 years at 3.5 interest. We have accumulated 72.0891. Okay, so now we need to figure out the second half because the interest rate changes. It's going to go up to 5% compounded semi-annually for the remaining 10.5 years. Okay, so we've got the same payment amount. So if we don't clear our calculator, if we don't click that clear work, it's still holding the payment amount. It's still holding the payments per year and the compounding per year, which is 2. We'd enter that under the previous conditions. But what we do need to change and enter in is our new IY. So we have 5 IY. We have 21N, and the reason it's 21 is because it's 10.5 years multiplied by 2 because of the semi-annual. And then now remember, because we're now in the second half, we're starting with something, right? Because we've already accumulated in the first 5.5 years, we've accumulated 72.0891. So we need to put that in as our present value. Okay, so we're going to put that in as 72.0891, and then again push the plus minus key to turn it into a negative, because that's money that's gone out of our pocket and into an investment. So 72.0891 plus minus key, and then present value, because that's the present value of all of this annuity accumulation already. So now, given these new circumstances, we want to hit compute future value. So after 10.5 years, under these conditions, our total amount that we're going to have in this investment is $28,417.91. So please make sure before you move on that you're able to calculate this, okay, and you get this answer. If not, please let me know and we can go over it. Okay. Okay. So that's the future value. So if we start with 0 and build, we get a future value. Now, looking at the present value of an ordinary simple annuity. Okay, ordinary simple means that the payments are due at the end of the month. We want to figure out what the present value needs to be. Okay, so if we know what the future value is, we want to figure out the present value. So the present value of an annuity is the sum of present values, all the payments calculated at the beginning of the term. So we could calculate the present value using our compound interest formulas and dealing with each payment individually, or we can do it using our financial calculator, and that's the part we're going to do. But the same with the other one. If you would prefer to do the formulas, please feel free to spend some time working on the formulas. Otherwise, let's focus on using the financial features of our calculator. Okay, so calculate the present value of a 10-year ordinary annuity with quarterly payments of $500 using a rate of 8% compounded quarterly. Okay, So we've got 8%. So we've got 8 IY, and it's ordinary annuity, so it compounded quarterly and quarterly payments. So that's what makes it an ordinary, because the compounding and the payments are at the same amounts. Okay, both of them are quarterly. Okay. So we need to go in and change the PY. So we need second, and then we click the IY button to bring us to the PY. 4, representing quarterly, enter, and then second, quit to bring us back up to the main level. 40, N, right, because it's 10-year ordinary annuity with quarterly payments. So 10 years times the 4 times per year gives us our N. So 40 N. We're making payments of 500, so 500 PMT. We want a 0 future value. Oh, and for your payment, don't forget to put in the plus minus button, okay? So 500 plus minus PMT to give you a negative 500 because it's a payment going out. We want the future value of this to be 0. And that's going to give us an answer, a present value of negative 13,677.74. So basically what this represents is if you want to be able to receive payments of 500 a month for the next 10 years on a quarterly basis, then you need to have $13,677.74 in your annuity. Okay, so I'm going to say that again just because I said monthly instead of quarterly. So think of this as a retirement annuity, okay? How much money do I need to have in there now so that over the next 10 years, I can take $500 out of it on a quarterly basis so that at the end of the 10 years, the amount left in that is going to be 0. Okay? And that says that the value of it needs to be $13,677.74. And this is just a visual so you can see. Okay, so let's put a name to that so that that value, that present value that we needed to have is what's referred to as the fair market value. Okay, so if we want $500 payments on a quarterly basis coming to us over the next 10 years so that at the end of the 10 years, the future value is 0, we need that present value or the amount saved to be the 13,744, I think it was. That's what's referred to as the fair market value. So the fair market value of an investment is the present value of the cash flows expected from the investment. Okay, so we expect the 500 quarterly for the next 10 years. So the present value of that cash flow is what's referred to as the fair market value. So if the investment contains regular payments, which was that 500, we can use the present value formula to help calculate the fair market value. And the payments are discounted at the current market rate of return. So in the last example, it was 8% compounded quarterly. Okay. So fair market value. Suppose the funds used to purchase an annuity will earn 6% compounded monthly. What amount is needed to purchase an annuity that's paying $1,000 at the end of each month for the next 20 years? So this is the exact same type of question. We want to know what the present value needs to be now so that we will be being paid the $1,000 at the end of each month for the next 20 years. And we know that the amount that is investment is going to be compounded monthly, and it's going to earn a 6%. Okay. So I don't have an illustration for the calculator doing the calculations, but we can definitely figure it out. Okay. So given the payment, we know that the payment is $1,000. Okay, I'm just going to put this information up here for the actual calculation. So think about it. If we look at our calculators, we have our N, which is the first one in line. So we know that it's being compounded monthly and paid monthly. So we know that it's 12 to represent monthly times 20 years gives us an N of 240. So we put in 240 N, okay? Then we know that our interest rate is 6, so we've got 6 IY, and then we've got to change our PY. So we go second IY to get to the PY level, and then we do the 12, enter. And then we do the second quit to come back up to the main level. We are calculating our PY, so we are not going to put that in. We know our payment is $1,000, so we want to put 1,000 plus minus button, and then click payment. We know that our future value is going to be 0 because once we take these payments out, we want to have a 0 at the end. So we're going to put in 0 future value, and then we're going to hit compute present value, and the present value it's going to give us is $139,580.77. So please make sure you're able to put this in your calculator in order to be able to figure out the present value again of the $139,580.77. So let me know if you have any questions, but please be sure that you're able to calculate that number at the end of trying this example. Okay, so let's move on to the next one. Okay, so an investment pays $50 at the end of every 6 months for 17 years. At the end of the 17 years, the investment will pay an additional $1,000 along with the last regular $50 payment. What is the fair market value of the investment if the prevailing rate of return on a similar investment is 8.5% compounded semi-annually? So again, the payments and the compounding are the same. They're both semi-annual or every 6 months. Now the one thing that's different here is that the investment will pay an additional $1,000 along with the regular last payment of $50. So that means that at the end, instead of us putting in 0 future value, it's going to have $1,000 future value. So we put in 1,000 future value before we did the compute present value. So let's go through it and see. Actually, we're just about to run out of time. We're at the 14-minute mark. I will create another video to go over the answer for this one. Thanks, everyone.